Hello and welcome to Dimensional Analysis 2. In this video, we'll look at two more problems, each of which has a little bit of a twist to it to make them just a little more challenging than the ones in our previous video. So make sure you have some pencil and paper and pen or calculator and your calculator available so that you can try these problems out as we're doing them together. All right, so our first problem involves a cup of cocoa again. It contains, as before, 493 milligrams of potassium, so 493 milligrams per cup of cocoa. And there are 16 cups of cocoa in 1 gallon. And your job is to determine the potassium content of cocoa in pounds of potassium per gallon of cocoa. So think about, there's a lot of more information in this problem, a lot more numbers running around, so it may be a little more challenging to find where we're starting with and where we're going here. All right, so we're going to start with what our content is in terms of our given information. We know there are 493 milligrams of potassium per cup of cocoa. And our goal, our question, our determine, or the how many, is to find out what that content is in terms of pounds of potassium per gallon of cocoa. So we've got those units that are in the top and the bottom. And as you can see from where we start and where we end, we're going to have to change our numerator unit, our milligrams, into pounds. So from one mass unit into another unit for weight. And then we're going to change our denominator, our bottom unit, from units of cups, which is, again, kind of a English system, our silly system unit of a volume measurement, into gallons, which is another one of those volume units, also still in our silly English system. So thankfully, we do have some information up above that tells us how many cups are in 1 gallon, in case you're not been in the kitchen and use that measuring system very often. We have that information on how those volume systems are related. So let's make a plan. We need to make a plan for that numerator part to change the mass from milligrams to pounds, and another plan, or the same plan, right? We'll just continue on in one big problem here to convert from cups into gallons. So I started with the numerator. So we'll start with milligrams per cup, and we'll change just the top unit. So one thing at a time, we'll focus on the top. So to get from milligrams to pounds, right, we had that conversion just in the last video. How to get from pounds to grams, it's the same to go from grams to pounds. So if we can get our milligrams into grams, then we can use that same conversion factor from last time. So we'll go from milligrams per cup to grams per cup, and then to pounds per cup. And then we will use the information in the story up there, how many cups are in a gallon, to convert our bottom unit in one step from cups to gallons. So from pounds per cup to pounds per gallon. So we're just going to do this all in one big sort of math problem. Again, if you like, you can always separate these problems with multiple units, units in the numerator and the denominator, into two separate problems. You can separate the numerator and denominator and then recombine them. It's just a little more efficient if you can be comfortable doing it all at once. All right, so we've got our plan now. We need to note what those conversion factors are. So some of them, again, are things we need to memorize. So that first one, a conversion, we had to memorize based on the prefix. Some of our conversion factors are going to be provided to you. So all those conversions from the English system to the metric system. So the middle one, the green one there, that's information I will give you. And then some of our conversion factors are ones that we think that you might have from experience. So again, if you don't have that experience of cooking and knowing how gallons and cups are related, you can always ask. But in this problem, we actually added that information for you. So we do have that conversion factor. So now we've done all the thinking. We've done the planning. We've located or remembered all of our conversion factors. So now we're ready to do the mathematical part of the problem. So we'll let the units do the work here to help us out. So we'll start with our 493 milligrams per cup. And now we've got our three conversion factors. So we will just go ahead and let the units tell us which part of that conversion factor goes in the numerator and what goes in the bottom. And it's all, remember, designed to cancel out the units we do not want, right? So they need to be across from each other, and to keep the units that we do want, whether it's in the numerator or the denominator. It works the same way. All right, so for our first conversion factor, we'll put our milligrams in the denominator so that it cancels with the milligrams that's already present in the numerator. And we'll put our grams in the numerator. Okay. Moving on to our next conversion, we want that grams to eventually go away. We're going to change it into pounds. So it's in the numerator now, so we'll put the grams in the denominator in our conversion factor. Right? We got to make sure we keep the number with the unit. Right? I know it's easier when the ones are on the bottom, but that doesn't always work out that way. Sometimes the problem is dictating that the 1 for the 1 pound is going to go on the top. So it's just a little more complicated in operating our calculators. So now we've dealt with the numerator. We've changed the numerator from milligrams into pounds. Now we need to change the denominator from cups into gallons. So note that the cups is already in the denominator. So if we want it to cancel, we're going to need to put the cups part of this conversion, the 1 gallon equals 16 cups. We're going to have to put that in the numerator. So the units of cup cancel out, and then our unit of gallon will be on the bottom. That goes with the 1 part of that conversion factor. So we can double check that our units are all going to work out now that we make sure we've written them down properly. So our milligrams cancel, our grams cancel, our cups cancel, and we're left with just units of pounds and gallons. Pounds in the numerator, gallons in the denominator, which is fantastic because that is what we were looking for, pounds per gallon. Now we operate our calculator. And our calculator, of course, gives us a great big long number with lots of digits in it. And we have to be smarter than that. We need to take a look back at our values that we used in our mathematics here and see which of them have significant figures, which of them are from definitions and have infinite significant figures. Okay, so only our first value was a measurement. So it has 3 significant figures. All of our other conversion factors are from definitions, either from what a prefix is, or from what cups and gallons are, or for how a pound is defined in terms of grams. So there should only be 3 significant figures in our answer here. Remember, those leading zeros are not significant digits, so we're not going to count them. We'll start counting with the 1, the 7, and the 3, and look what comes after the 3. It's a 9. So that 3 is going to round up. So our end result is 0.0174 pounds per gallon. Okay, here's another one to try. This one's different from the ones we've done before. So the question here is how far in inches, so I've specified what unit I want for that distance, how far in inches will light travel in 1.3 picoseconds. Okay, so we have to remember what that prefix is. It's pico. It means a very small amount, very short amount of time. And we also know that the speed of light is 2.998 times 10 to the 8th meters per second. Okay, so this is not unlike something you've probably thought about before, which is how far can I drive in a couple of hours if I'm going at a certain speed, right? How many miles will I go, right? If we're thinking in terms of miles per hour, if I drive for a couple of hours. We've done this problem. You've done this problem before, but not in this formalized way that we're doing it. So keep in mind that the speed of something, right? It's got those units of, this case, meters per second. It's telling you how a unit of distance, meters, is related to a unit of time, our seconds there. It's a conversion factor. So the speed is like a conversion between distance and time. So I'll let that be your little hint. I'll let you think about it for a few minutes. So pause the video, think about where we're starting, where we're going, how we might use that speed as a conversion factor, and see if we can get that set up. Okay, so we are going to start with the time. We're given a time constraint, 1.3 picoseconds, and we're asked how far. We want a distance. And in this case, you didn't get to decide what that unit was. I told you we wanted that unit in inches. So we need to find a way to convert from a time unit, picoseconds, into a distance unit of inches. And we have speed. The speed is our connection between time units and distance units, but it has a very particular value. The time needs to be in seconds, and our distance that we're going to find out about is going to be in meters. So we know what's going to happen in the middle of this problem. We know somewhere in the middle of this problem, we're going to be able to convert from seconds into meters. Somewhere in the middle of that problem. So that's kind of where I started my thinking about this, because I know that's the units of speed that I have, meters per second. So I know I need to get my time from picoseconds into seconds, and I know I'm going to have to get my distance from meters into inches at the end of my problem. So I've kind of broken up this problem into two pieces here. So I need to think about, can I get from picoseconds to seconds? And the answer should be yes, right? Those things are only different by a prefix. So we should be able to do that. And then to get from meters to inches, we've done this a couple of different ways. I chose to go from meters to centimeters, and then from centimeters to inches, using that definition that I will always provide for you. So here are what the 4 steps look like. So we'll go from picoseconds to seconds, so I get my time in the right units to use my speed as a conversion factor. Then I'll use my speed as a conversion factor to go from seconds into meters. Right? So you can see what's written right underneath that green arrow. It's just a way of rewriting that speed in something that looks like a conversion factor that we've been doing. Something equals something else. So in this case, it's 2.998 times 10 to the 8th meters equals 1 second. Okay. And then we've got a more familiar kind of problem at the end. We go from meters to centimeters using our prefix, and then from centimeters to inches using our definition of what an inch is. Okay. Now that we've done all that work and that thinking and that planning, now we can go ahead and set things up. So we've got, again, 4 steps here, so it's one of our longer ones. We'll start with our picoseconds, and then we'll put in all of our conversion factors, being mindful of the units and arranging them so that the ones we don't want cancel and the ones we do want stick around. And then when all of that is set up, we can then check that our units are arranged properly. So even though we arranged our values in there just so, we'll take a second and just check that that in fact was the case, that we didn't accidentally flip something over or get something written backwards. So our seconds cancel, our meters cancel, our centimeters cancel, and we have just inches left. And again, our calculator gives us a ridiculous number of digits, so we have to again go back and think about our significant digits. And we have 2 significant figures in the number we start with, an infinite number in almost all of our conversion factors, but the speed of light, we only have 4 significant digits in it. So again, we're limited by the smallest number, which is 2, so it happens to be our starting value. So we need to round that number, our result off from the calculator, to 2 significant digits. Again, remembering those leading zeros are not significant digits. So our answer is 0.015 inches. So in 1.3 picoseconds, light will travel just not very far at all, 0.015 inches. Well, thank you for joining me for Dimensional Analysis 2. There is one more video in this series. It will involve a little review quiz for you to check your knowledge and one more problem to practice with. See you then.